Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is an ortho-substituted benzene bearing a CHCl to side chain, a benzene with a 1,2-dichlorothyl group where the benzylic carbon carries 1 Cl and the terminal carbon carries 2 Cl atoms, i.e. PHCHCl-CHCl2 arrangement at ortho positions. Actually examining the structure more carefully, the compound is a benzene ring with at one position CHCl and at the adjacent position CHCl2, making it an ortho-bis chloromethyl type. One carbon has 1 Cl, benzylic CHCl, and another has 2 Cl, CHCl2. Moving on to the next step. HO acts as a base nucleophile. With 4 moles of HO reacting with 2 moles of substrate, that is 2 equivalents of HO per molecule of substrate. Moving on to the next step. The CHCl2 group undergoes elimination or substitution. With HO, the CHCl2 group loses HCl to form a CHCl via E2 or substitution, or the CHCl groups undergo intramolecular reaction. More precisely, O can deprotonate or substitute on the CHCl2 to give CHClO after loss of Cl. The benzylic CHCl can also react with HO to give CH or form an alkoxide. The key reaction, each CHCl2 group reacts with one OH to displace one Cl giving CHClO alkoxide, which then undergoes intramolecular cyclization. And for the final step, 2 molecules of the orthodihydride substrate react with 4 OH per molecule. Each molecule loses 2 HCl equivalents. The 2 benzylic CHCl groups from 2 different molecules couple through 2 oxygen bridges. 1 oxygen comes from each OH attacking the CHCl of one molecule, while the alkoxide from the other molecule displaces the Cl of the first, forming a symmetric dibenzo 1,4-dioxane. This gives a structure where 2 benzene rings are connected by 2 OCHCl bridges, the dioxane ring, with each bridging carbon retaining 1 Cl atom. Each bridging carbon originally had CHCl, benzylic, or CHCl2 terminal. After losing 2 close per molecule, 1 from each CHCl-CHCl2, 2 close remain per molecule, giving 4 close total in the dimer, symmetrically placed, 2 Cl on each side, 1 on each bridging carbon of the dioxane ring on each benzene unit, matching option B, which shows 4 close atoms symmetrically on the bridging carbons with no methyl groups. A has a methyl group which is not present in the starting material. C and D have incorrect substitution patterns or methyl groups inconsistent with the starting material. Option B correctly shows the symmetric 2,3-dichloro 2,3-dihydro 1,4 benzodioxane dimer with 4 close atoms on the bridging sp3 carbons. Therefore, the correct answer is B. Therefore, the correct answer is option B.